Hello, everyone. In this video, we are going to study indeterminate forms of type infinity over infinity and 0 over 0 as well as L'Hopital's rule for evaluating limits. Indeterminate forms. When evaluating limits, the initial result may be a couple of values that together does not tell the actual value of the limit. In other words, it is unclear whether the limit is a real number or an infinite number. A result in this form refers to an indeterminate form. There are 7 indeterminate forms: infinity over infinity, 0 over 0, 0 times infinity, infinity minus infinity, 0 raised to 0, 1 raised to infinity, and infinity raised to 0. These are called indeterminate because they do not tell exactly what the limit is. The actual limit may be a specific number or an infinity, or the limit does not exist at all. A strategy is to modify the function whose limit is to be evaluated in order to compute its limit. Let us first discuss why infinity over infinity is an indeterminate form before discussing a technique in evaluating this type of indeterminate form. Suppose infinity over infinity is equal to n. Then, infinity is infinity times n. And this equation is correct for many values of number n. Because of this, infinity over infinity could mean any value, finite or infinite, and it is therefore indeterminate. Now, let us discuss why 0 over 0 is an indeterminate form. Suppose 0 over 0 is equal to n. Then, 0 is 0 times n. And this equation is correct for many values of number n. Because of this, 0 over 0 could mean any value, finite or infinite, and it is therefore indeterminate. L'Hopital's rule. Suppose f and g are differentiable, except possibly at x equals c. The rule is applicable when finding the limit of f of x over g of x, as x approaches c. If the limit of the numerator and the denominator are both infinity or both 0, then apply L'Hopital's rule. The limit of f of x over g of x, as x approaches c, is equal to the limit of the derivative of f of x over the derivative of g of x, as x approaches c. The limit on the right side may exist, which means the limit is a specific number, or may not exist, which means the limit is infinite, or the limit does not exist at all. L'Hopital's rule is also applicable to one-sided limits. And limits at infinity. Strategy in evaluating limits using L'Hopital's rule. First, confirm that the limit of the numerator and the denominator are both infinite, or the limit of the numerator and the denominator are both 0. Use properties of limits, direct substitution, and common limit expressions, whichever may apply. Second, apply L'Hopital's rule. Third, differentiate and simplify. Fourth, Evaluate the limit using properties of limits, direct substitution, and common limit expressions. If the limit still yields an indeterminate form, repeat the application of L'Hopital's rule in the next steps. Examples. Evaluate the limit. Number 1. The limit of the sign of quantity x minus 2 all over quantity x cubed minus 6, as x approaches 2. Solution. If we evaluate the limit by direct substitution of 2, the limits leads the indeterminate form of type 0 over 0. To compute the actual limit, apply L'Hopital's rule. Differentiate the numerator and the denominator separately. And then simplify. Evaluate the limit by direct substitution to see if it leads to a finite or infinite number. Thus, the limit of the sign of quantity x minus 2 all over quantity x cubed minus 8, as x approaches 2, is equal to 1 over 12. Number 2. The limit of quantity 2x squared plus x plus 2 all over quantity x squared minus 1, as x approaches positive infinity. Solution. If we evaluate the limit using an infinite limit expression, the limit leads to the indeterminate form of type infinity over infinity. To compute the actual limit, apply L'Hopital's rule. Differentiate the numerator and the denominator separately. And then simplify. Evaluate the limit again by an infinite limit expression, which again leads to the indeterminate form of type infinity over infinity. Apply L'Hopital's rule again. Differentiate the numerator and the denominator separately. And simplify. Thus, the limit of quantity 2x squared plus x plus 2 all over quantity x squared minus 1, as x approaches positive infinity, is equal to 2. Number 3. The limit of the arc sine of x all over the natural logarithm of x, as x approaches 0 from the right. Solution. If we evaluate the limit using one-sided limit expressions, the limit leads to 0 over infinity, which is not an indeterminate form. This means that we should not apply L'Hopital's rule. Let us instead find another way of evaluating the limit. Rewrite the function as a product, and then apply the product rule. Use one-sided limit expressions of an inverse trigonometric and the natural logarithm functions. Then apply a property of infinite limits. Thus, the limit of the arc sine of x all over the natural logarithm of x, as x approaches 0 from the right, is equal to 0. Please watch the next part for more solved problems on indeterminate forms. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.